Okay, this is the second question. Before starting second question, I'll put the optional question here, and if I have time, I will update the homework, the exam. So as I mentioned earlier, it'll be interesting to think about hypothesis test of constant returns to scale. So like to do that, you are going to need to set up a test statistic. In this case, it's up to you. You may use wild test. You may use the restricted model, unrestricted model. It's totally up to you. So and everything is pretty simple. So you should be able to do this and construct test statistic based on your approach, and then show that the null hypothesis. So if your null hypothesis was correct, your test statistic would follow a chi-square distribution, and then critical value is like a 95 percentile or 0.95 quantile of the chi-square distribution. Like if you use 5% significance level, okay, and then you may need to think about computational issues. Like, can you just compute that, or right, how to calculate the variance? How if the test statistic involves unobserved variables, how would you handle that? Things like that. So what I want is not a detailed, rigorous, uh, rigorous derivations, but I just want you to be able to apply the idea to this simple model. It's pretty simple. So show me that you comprehend all the steps for hypothesis test. Okay. So the second question is about our old friend to economists, supply and demand model, right? So familiar. So I'll not discuss much about uh, what this means. So in here, we have endogenous variables Q and P, and exogenous variables X and Z. And there are error terms epsilon and psi, parameters alpha, beta, gamma, delta. So really standard. Everything is so simple. And here I will just say alpha, beta is supply parameters, gamma, delta are demand parameters. Right. So demand will be downward sloping, supply will be upward sloping, but mathematical expressions are the same. And then the first step I usually ask you to do here is deriving the reduced form approach, reduced form equations. That means you are going to calculate the quantity and price in terms of exogenous variables and parameters and the error terms. Exactly, this is what I like kind of theme in this final exam. You need to distinguish what is the cause, what is the result, right? So when those parameters, exogenous variables, and exogenous shocks are given, the equilibrium quantity and price are determined. That's the main point, okay? And of course, the new notation pi 1112 2122 and u1 u2 are just notation. They correspond to something based on structural parameters and structural error terms. So you have to express them. Uh, in that, by the way, in this derivation, it is so usually the mistake happens when something is too obvious, right? So in this derivation, you may have used division to solve these two system like these linear equations into this. You may need to use division, and then in doing so, you need to think about if the divisor is 0 or not, right? So this is really, really basic, but usually a lot of people forget this, and even I forget this a lot of times. But I'll just mention it. I thought about making that as a question, but it's so obvious. So and so this is the uniqueness condition in the end, or economically that is condition that the equilibrium is unique. And then just think about, it's not econometrics, but you can just think about when this is unique, when, if this condition is economically trivial. It is trivial in like economic sense, and just think about that as a practice. Okay, I will not make it a question. So here, and another thing I wanted to point out here is, so after transforming the structural equations into the reduced form equations, you know the main purpose is we would like to put the exogenous variables on the right hand side, and then each of the equations becomes just a one classical linear regression model without endogeneity. Okay, that is right. Then in class, I proceed as if it is so obvious. It is trivial. In some sense, that is right, but we cannot take it just as granted, right? You need to think about the basic assumptions like full rank assumption, exogeneity assumption, even though they are obvious, clear, right? I understand that, but like you have to make sure you are not dividing by zero. You have to think about like here the full rank assumption, for example. Exogeneity is so obvious, so I just give you a chance to think about that problem, and I want to point it out. So, right? So, just simple. It's not that difficult. And part C, now you have to invert the the reduced form parameters back to the structural parameters, right? So the problem here is it is not that difficult, just four simple parameters into four. So it should be easy, but here the problem is transformation is not linear. Like, so there is no standard way like matrix inversion. Here you have to solve them out by yourself, but not that difficult. But that is actually a problem in theoretical analysis and in estimation, right? So you will see something divided by something, like you will see divisions, fractions a lot in the expression. That is actually very it's not desirable in estimation context. Okay, just as a practice, and but it is okay to show that it is a good identification argument. Right? You can say that if the reduced form parameters are identified under these assumptions, then after this inversion, you can identify the structural parameters. But we are not going to use this method for estimation. And then part D, what is this? It is about endogeneity. So I wanted to show you the endogeneity in the structural equation. So basically, it is calculating covariances. That should be easy. Calculating covariance is easy, but again, I'd like to emphasize again, uh, like express endogenous variables in terms of structural parameters and structural variables, right? So otherwise, your covariance is going you are not analyzing it correctly, right? Um, so then in this case, still the reduced form equations are useful because when you calculate, for example, the covariance between P and epsilon, for example, then you are going to replace P with this. This is the exogenous, the expression of P using exogenous variables. Okay, so use this and calculate covariance based on this. Of course, U2 also depends on epsilon and psi, so use only the structural objects. Okay, so it'll be then simple. Keep that in mind where we are going. You are going to replace endogenous variables with underlying variables. And part E, so think about two-stage least squares, and again, it's same as pretty much the same as question 1. You have to include all exogenous variables in the first stage. Then you will find out actually you are going to have this equation again. So this reduced form equation is basically the reduced form equation in the two-stage regression, right? In the first stage regression, I mean, right? So they are basically the same approach, right? So it's another way to understand the fitting value approach. And then also, like you have done this earlier, so the same assumptions are needed to identify the two-stage least squares, right? So in the first stage regression of the two-stage least squares. So also, you cannot just take the first stage as granted. You need to think about the full rank assumptions or the potential multicollinearity there. Okay, and the main theme of this question is comparison between two-stage least squares versus GMM. F and G are about two-stage least squares variance only for the supply curve, and J and K in later part is about GMM for estimating supply and demand at the same time. So in other terms, in other terminology, two-stage least squares estimate the supply curve only. Then you may think it as a limited information approach. But GMM utilizes four exogenate at the same time. Then, like I mean, two curves at the same time, estimate all the parameters at the same time. Then it is a full information approach. In this example, in this question, in the end, the conclusion is that both are the same. Both are equivalent, like in terms of their asymptotic distributions. That will be your conclusion in part L. I'm telling you the answer. So in case if you made any algebra mistake, then you will see difference. But you should have the same asymptotic variance. However, this is not a general result. So we get both are the same because everything is linear. Everything is so simple. Everything is so linear. But something becomes nonlinear, they may be different, right? So keep that in mind. It's not a general result, special example. And in this question, the two-stage least squares is pretty much the same as question one, but I just need alpha, parameter alpha, which is price elasticity of supply, right? So you just take the variance of this guy. So as a result of the estimation, you are going to get 2 by 2 covariance matrix, but I only need 1, 1 element. The first element is the variance of alpha. Okay. And H, now you need to think about GMM. And remember, for estimation purpose, the moment conditions should depend only on observed variables and the parameters you are going to estimate. So it's a function of the parameters you are going to estimate, and then everything else must be observed because you have to estimate that, calculate that. And in this case, I recommend you to write the moment equation, moment function like this, right? Especially, I recommend you use this block diagonal structure. So put 0, 0, 0, 0 on these sides, non-diagonal blocks. Okay. Then the following algebra will be easier. I gave you a lemma below how you utilize the block diagonal forms. So then your algebra will be easier. And also, it will help you a lot if you define some notation for these things. Of course, all the question marks could be different things, and they all observe variables, right? So simplify the notation as you need, right? And finally, in GMM estimation, you need to think about the weighting matrix, right? And you know that the optimal weighting matrix is the inverse of the moment functions variance, okay? So you can check it in the textbook. Also, and another issue there was you may need a preliminary estimator because the optimal weighting matrix may depend on unknown parameters. So you have to estimate this parameter first, like find a consistent estimator for this unknown parameter first, and then calculate optimal weighting matrix, and then re-estimate the unknown parameters again with the optimal weight. That is a two-step procedure for optimal GMM method. But in this case, the answer is much easier. We learned it. We do not need to wait in some cases, right? So this is the answer to this question. You do not need to think much about waiting because it's so easy, so simple in this case. And question J and K are about asymptotic variance. And because we are estimating 4 parameters at the same time, the covariance matrix will be 4 by 4 matrices. So the weighting matrix will be also 4 by 4 because there are 4 conditional, moment conditions. But so 4 by 4 matrix is not easy to handle, but fortunately they are block diagonal matrices. So the algebra is easier than it looks when you use the structure, okay? And also, we are going to compare only for alpha, the variance only for alpha. So you do not need to calculate the second block at all, right? I only need like, so if you have 4 by 4, alpha, if this is a covariance matrix, alpha's variance will be the first 1 by 1, like 1 comma 1 element is the variance. So you do not need this part, right? Keep that in mind to simplify your algebra. So this will save you a lot of time. Also, in the question, I made this assumption. Epsilon and psi are 0. The random shocks to supply and demand are uncorrelated. But this is not necessary in our result. But this is to make the matrices block diagonal. So if you remove this assumption, still the result, all the results should be the same. But I guess like to my algebra, everything should be the same, but just more difficult, more unknowing algebra. Okay, so utilize this. Okay, so this is all I prepared. Good luck with the final exam. So I said, don't worry about the grade. Worry about your future. Of course, just a joke. And in this case, at this time, I will accept handwritten answers. I know you don't have enough time, so so if that is better for you, if you are willing to type, so like in my case, I would rather type my answer rather than writing down on paper. But if you prefer writing your answers on paper, that is okay. Just scan it or take a picture of your answers and send them to my email. And you have to worry more about your prelims. That should be your main priority. Okay. Thanks for your hard work for the semester, and so feel free to stop by. So after this course, maybe I'm not sure. I don't know how often we are going to see, but I would be happy to see you. I'm lonely in my office, so just say hello if you have time. Stop by my office. Okay. Good luck with your prelims. Bye.